Good day, Doctor. We are from Group 1, and now we will be presenting for our assignment, which is a time verifying field application. And we are trying to mimic the wireless device charger. And this is our group members. So, first of all, we have our leader, Chin Jin Shun, and I'm Ethan. We have Muhammad Mutasim, Sun Wei Song, and also Woon Jia Kwan as our team members.
For the introduction part, I will explain about the inductive power transfer, which named as IPT. It is a wireless power transmission technology that transfer energy through magnetic field. It is based on the theory of electromagnetic induction. We choose this topic is because nowadays IPT are more and more applied widely in the modern device such as the smartphone or smartwatch. It gives us a lot of benefits lah. Compared to conventional wiring charging, IPT offer better convenience and reduce cable damage. For this project, we will develop a simple IPT prototype to show how the wireless device charger work in the real life application.
Hi, Doctor. I'm Ethan, and now I'll be talking for the system design for our assignment. So, this is the design that we want to use, which is a wireless power transmission device. So, for the left side here is the transmission part, and the right side is mm, receiving part. The RL here we substitute it with LED. So for the electromagnetic theory that we use in our project is firstly Ampere's law, where when the BJT switching on and off the DC and turning it into an AC, the current will flow into the transmitter coil and create a time varying magnetic field that constantly expand, collapse, and flip polarity. And the second one is the Faraday's law, is when we move the transmitter and the receiving coil closer, the fluctuating flux will induce an EMF, electromotive force, across the receiving coil through the mutual inductance. And how we can see that is the LED will light up. Good day, Doctor. I'm Ethan. Now I'll be talking about the prototype for our project. So, as you can see here, this is a wireless power transmitter device. So, it is widely used in, for example, like wireless charger of a smartphone or smartwatch. So, it is consists of two main parts. The first one is the receiving coil, and another one is the transmitting coil. So, how we build the transmitting coil is that we take a enamel wire, roll it for 15 times, and then we take after 15 turns we take a center here and then we twist it, and then we roll for another 15 times, so it have 30 turns in total. And for the receiving coil we have 30 turns in total, and then just connect it to the LED. So we know that for the power to transmit wirelessly or through induction, we need a time varying magnetic field. So how we achieve that is by using a transistor here. This is a 2N2222A transistor. So we connect the base here to a 10 kilo ohm resistor, and then from the resistor to the one end of the transmitter coil. The reason for this resistor is to limit the amount of current going inside the transistor so it will not burn. And then we take the emitter part, connect it to the negative part of the battery holder, and the positive part of the battery holder is connected to the center of the loop here, and the collector is connected to the another end of the transmitter coil. So what will the transistor do is that it will switching the DC, because the voltage that we use is DC, and we know that in order to create a time varying magnetic field we need AC. So the transistor will change the DC into AC by consistently switching on and off the DC voltage. So now I will try to demonstrate how the thing works. So first of all, we plug in the battery here, 9-volt battery, and then this is the receiving coil, this is the transmitting coil. So we just put it like this. Wait. As we can see here, the LED is lighting up without the coil touching this, and this indicates that our prototype is working. So why the LED is not lighting up very bright is because we only have one battery and we are playing with it a lot, so the battery is kind of running low. So the maximum range that we can reach from this wireless power transmission is for now is 3 to 4 cm, and the brightest is when both the coil is not touching but very close to each other.
We choose the wireless charger because it is something we actually use in real life, but most people never think about how it's work. Wired chargers have problems. The connectors wear out over time, cables are annoying to plug and unplug, and they can even be unsafe in wet or industrial places. This topic also let us apply what we learned in class. Faraday's law and mutual inductance aren't just a theory. We could actually build a small coil system and watch it work with our own eyes. It was also simple and safe to build, but still gave us a clear result. When the LED lit up without any wire connecting it, that was our proof that the magnetic field was really transferring power. And beyond our small prototype, this same idea is already used in real life, in phone chargers, electrical vehicles, and even medical devices. So it's not just a classroom demo, it's a technology that actually shaping the future.
For our results, the prototype successfully demonstrated inductive power transfer. When we power the transmitter, the changing magnetic field induces a voltage in the receiver, lighting up the LED, giving us clear visual proof of Faraday's law in action. We tested the system across a 1 to 4 cm air gap. Performance was optimal at 1 cm. However, as we approached the maximum 3 cm mark, the LED grew faint and unstable. This is expected as magnetic flux linkage drops rapidly over distance. We also found that the system is highly sensitive to coil alignment, and the transistor produces mild heat during extended use. But overall, despite these limitations at maximum range, we successfully achieved our main objective, transferring electrical power wireless across the physical air gap. In conclusion, we have successfully translated Maxwell and Faraday's equation into a prototype. We have met our objective of designing, developing, and testing a functional wireless charger that demonstrates the true power of the electromagnetic theory in a real-world engineering.
So that is all from us. Thank you for your time and attention.